Right, 2018 paper, question 2D. Looking at a bit of important language here. It's about secondary schools. So there's 349 secondary schools. Of them, significantly for the question, 236 are 9 to 13 schools. The stats class knows how to have a good time, so the students were taking a random sample of 50 schools from that 349, and one student came up with 25 out of their 50 that were 9 to 13. Explain why the teacher might be suspicious. So I've got the working here for the expected, because we're told to compare expected with observed. Expect 236 out of 349, that's the figures. That gives us 0.672, or about 67-68%. If I take that probability and times it by the total number, so find the expected value, I get 33.8. If I compare that with the observed is 25. Both of those numbers are out of 50, arguably, so I could put that there just so that it makes sense. Okay, so has the teacher got justification for being suspicious based on the expected and the observed? Yes, maybe. There's quite a significant difference. We would expect that well over half of any sample would be year 9 to 13 schools, because well over half of the schools in total are. So yes, it's quite a bit below, so there's due reason for caution. Sadly, this is where the question goes completely awry, because in the second part, the teacher is vexed indeed by the situation, and the teacher is driven to do a simulation. I think the teacher maybe needs a hobby, but so they do a simulation, and they set the simulation up with the figures in the background. That's quite important. So there's 349 schools. The same 236 of them are years 9 to 13, and it selects them in bundles of 50. And from that bundle of 50, it counts how many of the schools are year 9 to 13, and the options range from out of the 50, very close, that looks like 44 at the top end here, down to what looks like about 22. Now, significantly, and they've done a bit of color coding, which is nice, of the simulation of 1,000 trials, we've got this wee bundle here. Now, these are significant. Not only are they red, but also they are the ones that are 24, 5, or indeed less. And that relates back to the student sample saying, oh, 25 out of my 50 were year 9 to 13. So based on this, what conclusion can the teacher make? We know that 25 is well below expected, so that is a worry. With the simulation, the key thing here really is this figure. If the simulation is done fairly, it happens 9 out of 1,000 times, or 0.9%. Or very crudely, if I wanted to do a bit of sensible rounding to talk about it, or roughly 1 out of every 100 trials. Okay, so based on the simulation, what conclusion could the teacher make? Well, there's two ways of looking at this. It could be reasonable. 1 time out of 100, 1 out of 100 samples, could give, 25 or less. So is it possible? Yes, but it's highly unlikely. And so the suspicions that something has been done, poorly in the sample selection is supported by this. So it's highly unlikely, and the cause for suspicion remains. The key thing here is we're taking this simulation. So the job of the simulation is to say, if those probability conditions were in place and we ran it a multitude of times, how often would this actually pop up? Still based on those probabilities. It is conceivable that it happens about 1 out of every 100. If the teacher has 100 students, then they would expect 1 to have this. So unlikely, but it could happen. And so again, it supports the idea for caution, but it doesn't write it off completely. Okay.